if my conceptual depth is better, if I can play the wizards of the topic, then solving any problem will be fun and play in physics. If the SI unit is not mentioned, please know 1 mark is taken off after doing so much of hard work. If you don't write the SI unit, 1 mark is taken off. Remember. Hello students. This is SD Sir again from the Temple of Excellence, Vidhyaashram, Pre-University, Mysuru. Dear students, in my today's session, I will work out a few problems from the unit Heat and Thermodynamics. Solving problems in physics is an art. Most of y'all find problems to be a problem in the exam. The last part, 5 problems are given, each of 5 marks, out of which 3 has to be solved. And understand, problems no longer remain problems if you are thorough with the concepts. If my conceptual depth is better, if I can play the wizards of the topic, then solving any problem will be fun and play in physics. So as I work out problems here, please do follow this session, understand the tricks and triggers. How do I go about with solving the problems? Now, understand, any problem to be solved, the first thing we rely upon is the collection of the data. What actually is given in the problem, the parameters which can come up to my help. Then I try to understand what actually has to be calculated. Once I know what is given, once I know the unknown, I will try to frame an equation between the known and the unknown. Good. So we start working out the first problem. Now, the problem says there is a metal bar of length 30 meters. A metal bar of length 30 meters and cross-sectional area 1 centimeter square. ನೋಡಿ, 2 ಇನ್ಫಾರ್ಮೇಶನ್ ನನಗೆ ಇಲ್ಲೇ ಸಿಕ್ತು. ಲೆಂತ್ 30 ಸೆಂಟಿಮೀಟರ್, area 1 centimeter square. I will write it down first. Length is 30 centimeter. Highlight this point. Wherever you solve problems, the units in SI system has to be followed. Proper conversions have to be made. ಇಲ್ಲಿ ನೋಡಿ, ಲೆಂತ್ ನ ಸೆಂಟಿಮೀಟರ್ ಅಲ್ಲಿ ಕೊಟ್ಟಿದ್ದಾರೆ, ಬಟ್ ಲೆಂತ್ ಹ್ಯಾಸ್ ಅನ್ SI ಯೂನಿಟ್ ಆಫ್ ಮೀಟರ್. How do you convert centimeter to meter? Divide by 100. So this becomes 0.3 meter. It was given in 30 centimeter I have converted into meters, 0.3 meter, and area is 1 into 10 power minus 4 meter square. It is used to transfer heat from 150 degrees Celsius reservoir to 0 degrees Celsius reservoir. Heat is transferred from 150 degrees Celsius reservoir to 0 degrees Celsius reservoir. Keep in mind, artha ಮಾಡ್ಕೊಳ್ಳಿ, higher temperature is always theta 1. So theta 1 is 150 degrees Celsius. Theta 2 is 0 degrees Celsius. Why this is not converted into Kelvin? Little later when I substitute, I'll tell you all. How much of heat is transferred in 5 minutes? See again, I have to calculate the amount of heat that is transferred in 5 minutes. So time is 5 minutes, which now has to be converted into seconds. SI unit of time is seconds. So this is 5 into 60, 300 seconds. K, thermal conductivity is given 427 watt per meter per Kelvin. So the first part, I have collected the data, whatever information, physical quantities I could pull up from the question I have taken. Now I have to calculate how much of heat, amount of heat energy. So Q, amount of heat energy that has to be transferred. Now I look for an expression which can relate Q with all these terms. And if you have listened to my session on thermal conductivity, we wrote an expression Q equals Ka theta 1 minus theta 2 into T by L. A very simple formula I have to remember, that's all. Q in terms of those 4 factors. Q equals K, A, theta 1 minus theta 2 into T divided by L. So this is, K was given to be 427, area 1 into 10 power minus 4, theta 1, 150 minus 0, time 300 seconds, length 0.3. Writing the formula will give you 1 mark, substitution 1 mark. Without any difficulty, you are getting 2 marks here. Celsius there, because I have taken the difference of those temperature. That is why I have not converted it to Kelvin. So this is equal to, you can use a simple calculator to simplify. No using scientific calculators, simple calculators. First, we will simplify the numerator. 427 into 1 into 150 into 300, so much, divided by 0.3. So, we get the answer as 6405 joules. So, after simplification, we get 6405 joules. So, this is the amount of heat that is transferred in 5 seconds. Sorry, 5 minutes or 300 seconds. Next problem. So if I work out one problem, I have a thought now, a process now, which I can employ to work out any other problem. A man wraps himself inside a blanket of thickness 50 centimeter. There is a man who is wrapping himself, who is placing himself. He's taking a blanket and putting it alongside him. Thickness of the blanket is 50 centimeter. So thickness is 50 centimeter, which is 0.5 meter. Now, 500 joule of heat is transferred. Amount of heat transferred ಕೊಟ್ಬಿಟ್ಟಿದ್ದಾರೆ. Q is given, which is 500 joules. So 500 joule of heat is transferred to the surroundings in a time interval of 3 minutes. Time interval ಕೊಟ್ಟಿದ್ದಾರೆ. So T is 3 minutes. 3 into 60, which is 180 seconds. If the temperature of the system is 200 degrees Celsius and the surroundings is 100 degrees Celsius, theta 1, 200 degrees Celsius, theta 2, 100 degrees Celsius. I have to find the thermal conductivity. Now, K has to be found out. Given the area is 2 into 10 power minus 4 meter square. Now, again, how will I relate K with these physical quantities? Simple. We have used the previous expression itself. So again, Q equals K A theta 1 theta 2 into T by D. Now what is that I have to find? K. I will have to manipulate that expression so that I am calculating K, thermal conductivity. So K becomes Q into D divided by A, theta 1 minus theta 2 into T. Again, just readjusting the expression. On readjusting the expression, now substitute. Q was how much? If I go back to the previous data, Q is 500 joules. So 500 into 0.5 divided by area is 2 into 10 power minus 4. 200 minus 100. Again, thickness. So time was 180. On simplification, again take your calculators, try to simplify. Very simple calculation. 70 watt per meter per Kelvin will be the answer. My dear students, after simplifying the entire problem, getting the answer, you have to mention the SI unit for the quantity you have calculated. If the SI unit is not mentioned, please know 1 mark is taken off. After doing so much of hard work, if you don't write the SI unit, 1 mark is taken off. Remember. Next question. 1000 joule of heat. Again, the first data given, heat energy, 1000 joules. So Q is 1000 joule of heat is lost from a heated slab of area 5 centimeters square. 5, it has to be converted into meters, minus 2 meter square. In 25 seconds, directly time is given. T is 25 seconds. If the temperature of the slab is 500 degrees Celsius and the surroundings is 300 degrees Celsius, so theta 1 is to higher temperature, 500 degrees Celsius, theta 2, 300 degrees Celsius. I have to calculate the thickness of the slab given K, thermal conductivity is 100 watt per meter per Kelvin. Marpuna yav formula upayogistira? Same one. Those 4 factors related to Q, rearrange, you get the answer. So I'm leaving this as an assignment for you all. I have given you the data, I have given you the expression, substitute, you get the answer. Next one. A boiler radiates 6 kilojoules of heat. Joule illa bari 6 kilojoule. So Q is 6 into kilo. How much is 1 kilo? 10 power 3 joule of heat at a temperature 800 degrees Celsius. So, and theta 1 is 800 degrees Celsius. Theta 2 is 400 degrees Celsius. The area of heat radiation is 3 centimeters square. Again, 9 into 10 power minus 4 meters square. Thickness of the boiler, again 0.5 meter. Time interval has to be calculated. Do I require some other formula? No. Nodi onde formula dalli ಎಷ್ಟು problem solve ಆಗ್ತಿದೆ. So Q is equal to K A. Q is equal to K A theta 1 minus theta 2 into T by D. Now T has to be calculated. Q is 6 into 10 power 3 kilo. K, value of K is 500 into 9 into 10 power minus 4, 800 minus 400 divided by 0.5. You have a T here. Simplify. So many seconds will be your answer. So very religiously you can follow. Write one expression, manipulate that equation, look for whatever has to be calculated, and you get the result. Now, next one, very interesting. Rectangular slab of copper has an area 100 centimeter square. Area 100 centimeter square, which you convert it into meter square. Thickness is equal to 4.5 into 10 power minus 3 meter. One face of the slab, one of the faces of the slab is in contact with steam at 100 degrees Celsius. Theta 1, 100 degrees Celsius, and the other face is in contact with ice at 0 degrees Celsius. So theta 2 is 0 degrees Celsius. It is found that, now see, there is an additional parameter given. 15 kg of ice melts in 1 minute. Mass of ice that melts is 15 kg. Time is 60 seconds. What is the thermal conductivity given latent heat? LF andre latent heat anta artha. LF of ice is 333 per kg. I use the same expression. Q is equal to K A theta 1 minus theta 2 into 1 by D. K has to be calculated. Area is known. Theta 1 minus theta 2 is known. T is known. D is known. But my primary information, Q itself is not known. For which I use this bit of additional information. My dear students, how did we define latent heat of fusion? LF is always Q divided by M. Remember, latent heat of fusion, LF is Q divided by M. Or from this, Q is LF into M. So can I not get Q from this expression? LF into M. LF is given. Mass is known. Substitute. Calculate Q. Once you get the value of Q, substitute back here and get me the value of T. So here you have seen, students, how one simple formula, if you take out your books, go through this session, again step by step you work out, the luxury is there, your calculator, very easily you can solve the numericals. In my next session, we will work out higher order numericals from this chapter. Until then, thank you.